A blacksmith is a metalsmith who creates objects from wrought iron or steel by forging the metal, using tools to hammer, bend, and cut. Blacksmiths produce objects such as gates, grills, railings, light fixtures, furniture, sculpture, tools, agricultural implements, decorative and religious items, cooking utensils and weapons. While there are many people who work with metals such as farriers, wheelwrights, and armorers, the blacksmith had a general knowledge of how to make and repair many things, from the most complex of weapons and armor to simple things like nails or lengths of chain. Origin of the term. The black in blacksmith refers to the black fire scale, a layer of oxides that forms on the surface of the metal during heating. The origin of smith is debated. It may come from the Old English word smythe, meaning to strike, or it may have originated from the Proto-German smithers, meaning skilled worker. Smithling process. Blacksmiths work by heating pieces of wrought iron or steel until the metal becomes soft enough for shaping with hand tools, such as a hammer, anvil, and chisel. Heating generally takes place in a forge fueled by propane, natural gas, coal, charcoal, coke or oil. Some modern blacksmiths may also employ an oxyacetylene or similar blowtorch for more localized heating. Induction heating methods are gaining popularity among modern blacksmiths. Color is important for indicating the temperature and workability of the metal. As iron heats at higher temperatures, it first glows red, then orange, yellow, and finally white. The ideal heat for most forging is the bright yellow-orange color, appropriately known as a forging heat, because they must be able to see the glowing color of the metal. Some blacksmiths work in dim, low-light conditions, but most work in well-light conditions. The key is to have consistent lighting which is not too bright. Direct sunlight obscures the colors. The techniques of smithing may be roughly divided into forging, welding, heat treating, and finishing. Forging, the process in which smiths shape metal by hammering, differs from machining in that forging does not remove any material, rather the smith hammers the iron into shape. Even punching and cutting operations by smiths will usually rearrange metal around the hole, rather than drilling it out his swarf. Forging employs 7 basic operations or techniques: drawing down, shrinking, bending, upsetting, swaging, punching, and forge welding. These operations generally employ hammer and anvil at a minimum, but smiths will also make use of other tools and techniques to accommodate odd-sized or repetitive jobs. Drawing lengthens the metal by reducing one or both of the other 2 dimensions. As the depth is reduced, or the width narrowed, the piece is lengthened or drawn out. As an example of drawing, a smith making a chisel might flatten a square bar of steel, lengthening the metal, reducing its depth but keeping its width consistent. Drawing does not have to be uniform. A tapir can result as in making a wedge or a woodworking chisel blade. If tapered in 2 dimensions, a point results. Drawing can be accomplished with a variety of tools and methods. 2 typical methods using only hammer and anvil would be hammering on the anvil horn, and hammering on the anvil face using the cross peen of a hammer. Another method for drawing is to use a tool called a fuller, or the peen of the hammer, to hasten the drawing out of a thick piece of metal. Fullering consists of hammering a series of indentations with corresponding ridges, perpendicular to the long section of the piece being drawn. The resulting effect will look somewhat like waves along the top of the piece. Then the hammer is turned over to use the flat face, and the tops of the ridges are hammered down level with the bottoms of the indentations. This forces the metal to grow in length much faster than just hammering with the flat face of the hammer. Bending. Heating iron to a forging heat allows bending as if it were a soft, ductile metal, like copper or silver. Bending can be done with the hammer over the horn or edge of the anvil, or by inserting a bending fork into the hardy hole, placing the workpiece between the tines of the fork, and bending the material to the desired angle. Bends can be dressed and tightened, or widened, by hammering them over the appropriately shaped part of the anvil. Some metals are hot short, meaning they lose their tensile strength when heated. They become like plasticine. Although they may still be manipulated by squeezing, an attempt to stretch them, even by bending or twisting, is likely to have them crack and break apart. This is a problem for some blade-making steels, which must be worked carefully to avoid developing hidden cracks that will cause failure in the future. Although rarely hand-worked, titanium is notably hot short. Even such common smithling processes as decoratively twisting a bar are impossible with it. Upsetting is the process of making metal thicker in one dimension through shortening in the other. One form is to heat the end of a rod and then hammer on it as one would drive a nail. The rod gets shorter, and the hot part widens. An alternative to hammering on the hot end is to place the hot end on the anvil and hammer on the cold end. Punching may be done to create a decorative pattern, or to make a hole. For example, in preparation for making a hammerhead, a smith would punch a hole in a heavy bar or rod for the hammer handle. Punching is not limited to depressions and holes. It also includes cutting, slitting, and drifting, all done with a chisel. Combining processes. The 5 basic forging processes are often combined to produce and refine the shapes necessary for finished products. For example, to fashion a cross-peen hammerhead, a smith would start with a bar roughly the diameter of the hammer face. The handle hole would be punched and drifted, the head would be cut, the peen would be drawn to a wedge, and the face would be dressed by upsetting. As with making a chisel, since it is lengthened by drawing, it would also tend to spread in width. A smith would therefore frequently turn the chisel to be on its side and hammer it back down, upsetting it, to check the spread and keep the metal at the correct width. Or, if a smith needed to put a 90-degree bend in a bar and wanted a sharp corner on the outside of the bend, they would begin by hammering an unsupported end to make the curved bend. So they would hammer the ends of the stock down into the bend, upsetting it at the point of the bend. They would then dress the bend by drawing the sides of the bend to keep the correct thickness. The hammering would continue, upsetting and then drawing, until the curve had been properly shaped. In the primary operation was the bend, but the drawing and upsetting are done to refine the shape. Welding is the joining of the same or similar kind of metal. A modern blacksmith has a range of options and tools to accomplish this. The basic types of welding commonly employed in a modern workshop include traditional forge welding as well as modern methods, including oxyacetylene and arc welding. In forge welding, the pieces to be joined are heated to what is generally referred to as welding heat. For mild steel, most smiths judge this temperature by color. The metal will glow an intense yellow or white. At this temperature, the steel is near molten. Any foreign material in the weld, such as the oxides or scale that typically form in the fire, can weaken it and potentially cause it to fail. Thus, the mating surfaces to be joined must be kept clean. To this end, a smith will make sure the fire is a reducing fire, a fire where at the heart there is a great deal of heat and very little oxygen. The smith will also carefully shape the mating faces so that as they are brought together, foreign material is squeezed out as the metal is joined. To clean the faces, protect them from oxidation, and provide a medium to carry foreign material out of the weld, the smith will sometimes use flux, typically powdered borax, silica sand, or both. He will first clean the parts to be joined with a wire brush, then put them in the fire to heat. With a mix of drawing and upsetting, the faces will be shaped so that when finally brought together, the center of the weld will connect first and the connection will spread outward under the hammer blows, pushing the flux and foreign material out. The dressed metal goes back in the fire, is brought near to welding heat, removed from the fire, and brushed. Flux is sometimes applied, which prevents oxygen from reaching and burning the metal during forging, and it is returned to the fire. The smith now watches carefully to avoid overheating the metal. There is some challenge to this, because in order to see the color of the metal it must be removed from the fire, and this exposes the metal to air, which can cause it to oxidize rapidly. so the smith might probe into the fire with a bit of steel wire, prodding lightly at the mating faces. When the end of the wire sticks onto the metal, it is at the right temperature. The smith will commonly place the metal in the fire so as it can be seen without letting the surrounding air come into contact with the surface. Now the smith moves with rapid purpose. The metal is taken from the fire and quickly brought to the anvil. The mating faces are brought together, the hammer lightly applying a few taps to bring the mating faces into complete contact and squeeze out the flux, and finally return to the fire. Again, the weld was begun with the taps, but often the joint is weak and incomplete. So the smith will again heat the joint to welding temperature and work the weld with light blows to set the weld and finally to dress it to the shape, finishing depending on the intended use of the piece. A blacksmith may finish it in a number of ways. A simple jig that the smith might only use a few times in the shop may get the minimum of finishing. A rap on the anvil to break off scale and a brushing with a wire brush. Files can be employed to bring a piece to final shape, to remove burrs and sharp edges, and to smooth the surface. Heat treatment and case hardening to achieve the desired hardness. The wire brush, either as a hand tool or as a power tool, can further smooth, brighten and polish surfaces. Grinding stones, abrasive paper, and emery wheels can further shape, smooth and polish the surface. A range of treatments and finishes can inhibit oxidation of the metal and enhance or change the appearance of the piece. An experienced smith selects the finish based on the metal and on the intended use of the item. Finishes include paint, varnish, bluing, browning, oil, and wax. Blacksmith Striker. A blacksmith striker is an assistant, whose job it is to swing a large sledgehammer in heavy forging operations, as directed by the blacksmith. In practice, the blacksmith will hold the hot iron at the anvil in one hand, and indicate where the iron is to be struck by tapping it with a small hammer held in the other hand. The striker then delivers a heavy blow with the sledgehammer where indicated. During the 20th century and into the 21st century, this role has been increasingly obviated and automated through the use of trip hammers or reciprocating power hammers. The blacksmith's materials. When iron ore is smelted into usable metal, a certain amount of carbon is usually alloyed with the iron. The amount of carbon significantly affects the properties of the metal. If the carbon content is over 2%, the metal is called cast iron, because it has a relatively low melting point and is easily cast. It is quite brittle, however, and cannot be forged, so therefore not used for blacksmithing. If the carbon content is between 0.25% and 2%, the resulting metal is tool-grade steel, which can be heat-treated as discussed above. When the carbon content is below 0.25%, the metal is either wrought iron or mild steel. The terms are never interchangeable. In pre-industrial times, the material of choice for blacksmiths was wrought iron. This iron had a very low carbon content, and also included up to 5% of glassy iron silicate slag in the form of numerous very fine stringers. This slag content made the iron very tough, gave it considerable resistance to rusting, and allowed it to be more easily forge-welded, a process in which the blacksmith permanently joins two pieces of iron, or a piece of iron and a piece of steel, by heating them nearly to a white heat and hammering them together. Forge welding is more difficult to do with modern mild steel because it has a narrower band of temperature at which it will weld. The fibrous nature of wrought iron required knowledge and skill to properly form any tool, which would be subject to stress. Modern steel is produced using either the blast furnace or arc furnaces. Wrought iron was produced by a labor-intensive process called puddling, so this material is now a difficult-to-find specialty product. Modern blacksmiths generally substitute mild steel for making objects traditionally of wrought iron. Electrolytic process pure iron is sometimes used. Many blacksmiths also incorporate materials such as bronze, copper, or brass in artistic products. Aluminum and titanium may also be forged by the blacksmith's process. Each material responds differently under the hammer and must be separately studied by the blacksmith. Terminology. Iron is a naturally occurring metallic element. It is almost never found in its native form in nature. It is usually found as an oxide or sulfide, with many other impurity elements mixed in. Wrought iron is the purest form of iron generally encountered or produced in quantity. It may contain as little as 0.04% carbon. From its traditional method of manufacture, wrought iron has a fibrous internal texture. Quality wrought iron blacksmithing takes the direction of these fibers into account during forging. Since the strength of the material is stronger in line with the grain than across the grain, most of the remaining impurities from the initial smelting become concentrated in silicate slag trapped between the iron fibers. This slag produces a lucky side effect during forge welding. When the silicate melts, it makes wrought iron self-fluxing. The slag becomes a liquid glass that covers the exposed surfaces of the wrought iron, preventing oxidation which would otherwise interfere with the successful welding process. Steel is a mixture of iron and between 0.3% to 1.7% carbon by weight. The presence of carbon allows steel to assume one of several different crystalline configurations. Macroscopically, this is seen as the ability to turn the hardness of a piece of steel on and off through various processes of heat treatment. If the concentration of carbon is held constant, this is a reversible process. Steel with a higher carbon percentage may be brought to a higher state of maximum hardness. Cast iron is iron that contains between 2.0% to 6% carbon by weight. There is so much carbon present that the hardness cannot be switched off. Hence, cast iron is a brittle metal, which can break like glass. Cast iron cannot be forged without special heat treatment to convert it to malleable iron. Steel with below 0.6% carbon content cannot be hardened by simple heat treatment enough to make useful hardened steel tools.